Hello guys, welcome back to Maths on African Motives, still on our revisions for engineering science N4. We shall be trying by all means to be working on the question paper of April 2023, that is on the hydraulic section. That was question number 6. This being a request from our members to work on this question paper or to work on this question. So make sure that you join the membership so that you can request for any question that we can work on as we are revising. This helps us to grow this channel each and every day, bringing you guys every information that you need to prepare for your exams. So thank you for those who are part of the members, and to all our subscribers. If you are not yet part of our subscribers, you can subscribe so that you become part of this channel, and also to join membership, which enables us to grow each and every day. So anyways, guys, I'm not going to waste much of your time. Let us quickly rush through the question that we are given, which was on question number 6. We are given the first part of our section. Let us have this. A single acting hydraulic press has got a plunger diameter of 55 millimeters, a stroke length of 106 millimeters, and a ram diameter of 140 millimeters. Calculate the volume of the liquid per stroke. All right. We've got the information that we're going to consider on the ram, and also the information that you're going to consider on the plunger. In this case, like I say, please list down your information, write down the information so that you understand what the question is all about. So we have got 6.1. So, okay, sorry for that. We are given the information on the plunger and also the information on the ram. So we have got the plunger in this case. Then we have got the information on the ram. All right, so on the plunger, I'm just going to use small letters for diameter, for force. For the ram, I'm just going to use capital letters for force and diameter. Okay, this, or you can just write the way that you understand. All right, so we are given that the plunger diameter is 55 millimeters. I'm just going to use the small d for the diameter, which is 55 millimeters. So if you can convert this to meters, divide by 1,000, we are going to have 0, 0. That will be a 0 there. All right, that will be 0.55 in meters. Then we also have a stroke length of 106 millimeters. So given the stroke length of 106 millimeters in this case, which is 2 meters, is going to be 0.106 in meters if we divide by 1,000. Then also, and the ram diameter of 144 millimeters. So on the ram here, we are given the diameter that is corresponding to the ram of 144 millimeters, which is going to be 0.144 in meters. That's the information that we have in this case. All right, then from this information, the question is calculate the volume of the liquid per stroke, the volume. All right, how are we going to have the volume in this case? All right, we understand that the volume can be taken from area times the stroke length. All right, this is what we're going to have. On this section, we do not have the corresponding height in this case, because if we had the corresponding height, the volume was going to be the area times that corresponding height, but we do not have that. Here, if we check, we have got the diameter, we've got the stroke length, so we can calculate the volume because we're going to consider the volume as the area, in this case, times the stroke length, which is the height, the length that we are given, our stroke length. In this case, that's our h. So how are we going to have the area? That is the question. So the area from the diameter, we understand that area is equivalent to pi d squared over 4. So we're going to use pi d squared over 4 times the stroke length, which is the height. So that's how we are going to have the volume in this case. So we have got area times stroke length. Same, even in our mathematics, if you calculate the volume of a solid, if you do, as long as you talk of a solid, it's the base area times the height. The base area. This is the same concept that we are having area times the stroke length, which is the height in this case. But here we do not have the corresponding height of the ram. We have the stroke length from the plunger. So we're going to use the information of the plunger. Remember, these two, they must be equal. So we're going to have pi d squared over 4. Okay, sorry for that. Let us just have our question here. All right, almost can be clear on this side here. Okay, sorry for that, guys. So we're just going to substitute our values. So you're going to have pi times the diameter in meters. So this diameter is supposed to be in meters, which is 0.055 squared over 4 in this case. All right, times the length, which is the stroke length of 0.106 in meters. So that is the condition that you're gonna have. All right, so from this we are going to obtain, or we are going to have our volume as that was going to be 0 comma something like that, 0.00025183 and so on. So to 3 decimal place, that was going to be, all right, so this was a 3. All right, so that was gonna be 0.00003, right? Let me just also confirm, because remember the issue of a calculator. If the issue of a calculator, guys, let us just see on the screen so that we round off together properly. All right, so let us see on the screen here. So we've got our fraction, that is gonna be pi times 0.055 squared over, that's 4, times the length of 0.0, okay, 0.1, sorry, 0.6, like this. All right, so that's gonna be, all right, I didn't multiply here, sorry for that. Okay, so if you had to check, it is to the exponent of -4 in this case. We've got, meaning to say, we've got about 4 zeros that you're gonna have. So you can just write it this way so that you do not confuse the issue of the zeros. But in actual sense, it's something like this: 2,518. So we're just gonna write it this way, 2,518, so that we do not have a confusion here. So it's going to be 2,518 to the exponent of -4 times 10 to the exponent of -4. So that's times 10 to the exponent of -4. All right, sorry for that. To the exponent of -4. So that will be our volume in cubic meters. All right. So if you wanted then to write in terms of the decimal part, you're gonna move the commas. 2,5 times 10 to the exponent of this was gonna be something like 1, 2, 3, 4, something like this. All right. So you end up with 0,0002518, like that, which is round off. This will be 0,0003 in cubic meters. But the answer there will be a little bit affected because of the digits that we are having. We have got a lot of zeros, but still you can write the same answer like that, or you can just write it this way. It's one and the same thing, right? So that was going to be the volume per stroke. Okay, so remember, you're not given the number of pumping strokes, like is it gonna be 3 or 4? Just we just calculate our volume direct like that. Okay, then the other part that we are given was to calculate the force exerted by the ram if the force of 75 Newton is applied on the plunger in this case. All right, so we've got the force of 75 Newton on the plunger. So we've got another information to consider, the force on the plunger here, which is 75 Newton. Then we are asked to calculate the force that is going to affect on the ram. All right, so how are we going to end up with the force that is going to be affected, or the force that we're going to have on the ram in this case? All right, remember we talked about these formulas. All right, just here I did not include my formula sheet when I was preparing this, but remember that the force that we gonna have in terms, we can relate in terms of the diameters. We can relate in terms of the force depending with the idea that you understand, all right? So if I want to relate in terms of the diameters, it follows that the force that is going to affect the ram in this case over its diameter squared is equal to the force on the plunger over the diameter squared on the plunger in this case. So what does it simply means is that I can calculate this F if I just do multiply here by E squared to remove this one. Remember, this one is for the ram. So at the moment I multiply this, I'm going to remain with F. So that means the force on the ram in this case is going to be equal to the force on the plunger, diameter squared times the diameter squared of the ram in this case. All right, so we have everything in this case. We're just going to simply substitute the force on the ram, which is 75. So this will be 75 over d squared from the ram, this small letter d, like I said, for the ram. So it's going to be 0.055 squared times the diameter on the this one from the plunger, the smaller one from the plunger, then the capital letter D from the ram in this case, which is 0.144 squared. All right. The other thing also, as we can check, this is diameter squared over diameter squared, this one. So even if you use your units in millimeters, they do not affect because we are dealing with the same units in this case. But just for the sake of revision to say we are working with meters, on the other part, you work with millimeters, you end up confused. So that's why I'm just maintaining the meters in this case. But on this formula, it does not affect whether you use millimeters or you use meters. You're going to have one and the same thing. So that is going to give us the force on the ram, which was going to be 514,116 Newton in this case. All right. So that was the idea there. That is this one directly from our engineering science N3. If you check the first question, second question, this is our N3. They just repeated what we talked about in our N3, if you still remember these things, guys. All right. Anyways, let us see question number 6.2. We are given on 6.2 that we've got a hydraulic accumulator is to work under a pressure of 2 megapascal. So we are given the pressure where it is operating at. So the operating pressure is at 2 megapascal in this case. Calculate the mass that is needed for it to act under the pressure of 2 megapascal, which means the same pressure, if the ram is a mass of 750 kilograms and a diameter of 450 millimeters. All right. So we take note here, we need the mass that's gonna need it for this. We need a certain mass that is gonna be needed, the mass needed. But having the mass of the ram in this case, so what about this mass that is needed? What is it representing? Where is it coming from? This mass that we are talking about is an additional mass. The normal mass that we are supposed to have is 750 kilograms for the ram. So this M needed is the additional mass in this case. So we are talking about additional mass. All right. So this represents the additional mass. To act or to operate under the 2 megapascal pressure that we are given, but given the information about the ram that it has, in this case, the mass that is gonna having on the ram in this case, let me just use M ram like this so that we do not confuse between the additional mass and the ram. So here I'm just gonna write ram. This is the mass of the ram, which is 750 kilograms, and the diameter of the ram in this case being 450 millimeters. To convert to meters, if we divide by 1,000, that will be 0.45. So you're going to have 0.45 in meters. All right. So that is what you're going to have as the diameter. So the question is, we need the additional mass. Where are we going to have this additional mass? All right. The concept is that let us bring back our formulas here. Let us understand our question. We have the mass of the ram in this case. Together, these must give us a certain mass. That is the total mass of what we have on the ram and what was added, because this is an additional mass. You are adding this mass. It's an additional mass. So meaning to say, we can formulate something to say the total mass of everything, we can just write as MT for the total mass is going to be the mass that we had from the RAM. So I'm just going to write R in this case, plus the mass that we have added, which is our additional mass. I'm just going to write as MA. Do not confuse, guys. R for the RAM, A for the additional mass, T for the total mass. So this is what we need. We need to calculate the additional mass that was added, this one. So it means we can make it the subject if we have the total mass minus the mass on the RAM, we are going to have the additional mass. So this is the formula that we are going to use to find our additional mass. That is, the additional mass is the total mass minus the mass from the RAM. But the question is, where are we going to have the total mass? This is the formula that we're going to use. Yes, but where are we going to have the total mass? We have the mass on the RAM in this case, but what about the total mass? Where are we going to have it from? So the total mass, we are going to work it from the pressure. Remember, it is supposed to operate under a certain, it must operate, it must act at a pressure of what? At a pressure of 2 megapascal. So from this pressure that we are working, what is it that we're going to have? We know, okay, let us talk about the pressure itself. Remember that pressure, the total pressure that we are supposed to operate at is at 2 megapascal. So this is where we have our total pressure. And this total pressure is supposed to be equivalent to the force over the area. So the force that we have, remember, force simply is taken from the mass times the gravitational acceleration in this case, which is actually the weight in this case. Let us put it in a correct way. This pressure is supposed to be the weight over the area, whereby we are saying the weight is simply the mass times the gravitational acceleration. Since we are taking it from the total pressure, the pressure that it is supposed to operate at, it means this is the total work done, which was taken from the total mass. So it means the mass that we are seeing here is going to be the total mass. So we are going to calculate the total mass from the pressure that we are given. So here we are going to calculate first the total mass. Calculate the total mass. All right. So the total mass is our MT, which is going to be from the weight that we are going to find here. So meaning to say that we can just, since the weight is the one that carries the mass, calculate the weight. How can you calculate the weight? Simply cross multiply 1 times this. We're going to have our weight being equal to pressure times the area. So that means, remember area here, we've got the area that pi d squared over 4. We talked about this here. All right, maybe I removed it's on the top, but I talked about the formula that is pi d squared over 4. So that means we are going to have the weight being equal to the pressure times the area, which is pi d squared over 4. So let us substitute so that we calculate the weight in this case. All right, so the weight from the pressure that we are given, our pressure is 2 megapascal, which is 2 times 10 to the exponent of 6 times the area, which is pi times d squared. Remember, we're given the diameter of 0.45. All right, that's 0.45 squared over 4 in this case. All right, so that was going to give us the total weight, which was going to be 31808 6086,2562 in Newton. In this case, remember, weight is force. Force is measured in what? In Newton. So like I said, force being mass times acceleration. If it is weight, it's mass times the gravitational acceleration. And this mass is the total mass for us to obtain, or to have the total weight, to have the total pressure. So it means we can calculate the mass from this part, because we are saying the total mass times gravitational acceleration is equal to this weight. So in order for us to obtain the mass, we are simply going to divide by the gravitational acceleration. So the total mass was going to be the weight over the gravitational acceleration, whereby we have got this weight of 318,086,2562, everything over 9,8. All right, so let us have the total mass in this case. So our total mass was going to be given as 32,000. All right, so that's 32,457.781 kilograms. All right. Since we have the total mass in this case, that means we can be able to calculate or obtain the additional mass, because we are saying from this formula that we are working with, our additional mass is going to be the total mass, which is the one that we calculated from the pressure that we are given. So we are going to have this as all right, we're going to have this as here we got 32,457. So this is the value that we obtained here. That's 32,457,781 minus the mass on the RAM in this case. And the mass on the RAM, we are given this as 750 kilograms. So we are going to subtract 750 kilograms from the total mass. So if we subtract 750 kilograms, we are going to obtain the additional mass in this case. So our additional mass was going to be 31,707,781 kilograms. This is the one that we need in order for this accumulator to be operating at a pressure of 2 megapascal that we are given. For it to operate, this is the additional mass that we are supposed to have to add to the one that we had before of the RAM, so that it operates at 2 megapascal. All right, so that's it for marks, which is just an understanding. If you work out your questions properly, you'll see that it's one and the same. Okay, 6.3, we have got the information that we need to consider on question 6.3, whereby we are given the information in this case on a water pump. All right, so let's see what you're given. So we've got a water pump delivers 12.5 liters of water per stroke. Each and every stroke, it is going to have a volume of 12.5 liters. Remember, liters, it's volume. We're talking about the volume that is being delivered per stroke in this case. All right, so we've got the volume per stroke, which is 12.5 liters per stroke. All right, so that is the idea that we have in this case. So if we are to consider that a liter, considering in terms of cubic meters, because we want to work in something that we understand. Remember that in a liter, we've got 1 kilogram if you want to consider in terms of mass, but in terms of volume, all right, so let me write this. A liter is equivalent to 1 kilogram, but in terms of volume, 1,000 liters actually, all right, we read from 1,000 liters. 1,000 liter, which is a kiloliter, it is equal to 1 cubic meter. A kiloliter, 1 kiloliter, which is 1,000 liters, is equivalent to 1 cubic meter. So it means in order for us to have a relationship between 1 liter to a cubic meter, in this case, we're just gonna divide by 1,000. So the moment I divide by 1,000 here, by 1,000 here, it means I've got 1 liter. So 1 liter is gonna be equal to 1 over 1,000 cubic meters, or 0.001 cubic meters. Each liter is gonna be equal to 0.001 cubic meters. So if I've got 12.5 liters, what am I going to do? I'm just going to multiply by this value. So it's 12.5 times this value, 12.5 times 0.001 cubic meters. We're going to have our volume in cubic meters, which is going to be 0.0125 cubic meters. Remember, this is volume per stroke. So meaning to say our volume per stroke in cubic meters is 0.0125 cubic meters per stroke. All right, so that's the idea of your conversion. Or you can simply convert it direct to say, if we are saying 1000 liters is equal to 1 cubic meter, what about 12.5 liters? 12.5 liters is our main. So you can just use it direct. So it's going to be 12.5 over 1000 times 1 cubic meter. You can convert it also like that. You obtain the same thing or the same answer. All right. Then we are also given if the effective force on the piston is 75 kilonewton. So we've got the force that is acting, which is the effective force of 27 kilonewton. And the diameter of the piston in this case is given as 250 millimeters, which is 0.25 meters. Calculate the stroke length of the piston. All right, we are asked to calculate the stroke length of the piston, which is L. All right. If we are to consider what we have in this case, on this part alone, it tells us a lot. We are given the volume per stroke, the volume per each stroke. So how can we calculate the stroke length? Remember the concept of volume. I talked about this on the first question, that where I said the volume was simply taken from the area times the stroke length. So from the volume per stroke, because it's taken per each stroke, we're going to consider it per stroke. What is going to be length of the stroke when taken per single stroke? That is the question then. So meaning we can apply this concept because we know that we have the volume and we can calculate the area from the diameter. That means we can make this the subject, just divide by L, by A, because we want to calculate the stroke length. So you're going to divide by the area. So that means our stroke length is going to be given as the volume over the area, whereby our area is given by pi d squared over 4. So you're going to have V over pi d squared over 4. So that's what we're going to have in order to obtain the stroke length, whereby we have the volume in this case in cubic meters 0.0125. So you're going to have 0.0125 in cubic meters. All right, over the area, that is pi times d squared, our diameter in meters, that's 0.25 squared over 4. So that is going to give us our stroke length in meters. Remember, this is area square meters, the volume cubic meters, area square meters. So cubic meter and square meter will give us the meters. All right, so anyways, our stroke length was going to be given as 0.254647 and so on. So it's going to be 255 in meters. All right, so that was how we could have calculated our stroke length. It was a direct question. As you can see, it was just a question on the manipulation of the formula. You were just supposed to manipulate your formula. Then from there, they need us to calculate the work done per stroke. Remember, we've got the volume per stroke. So, and we calculated the stroke length. So what is going to be the work done? All right, 6.32. So remember, the work done is force times distance. That is the formula for work done, force times distance. The distance that is being traveled, or the distance that is being taken in this case, is our stroke length. So meaning to say our work done is going to be force times the stroke length. And we have the force here, force 27 kilonewton. So you're going to have the force of 27 kilonewton in this case times the stroke length of 0.255. Remember, this stroke length is calculated when we had a volume per stroke. So this will be the work done per stroke also. All right. So that is the idea in this case. All right. So if we multiply these two, we are going to obtain 6885, which is in joules. Remember, work done. Or we can have this in kilojoules, which is 6.885 in kilojoules if we divide by 1,000. So that is the condition, or that was the condition of our question to calculate the work done per stroke. And you can see 2 marks for that. So that is it. 13 marks on this question of hydraulics. Let us keep on revising. As you can see, this exam was a little bit easier for April 2023 in terms of hydraulics section. We know that hydraulics, they don't play, but in this case, they just tried to bring us back to our N3 to revise from our N3 engineering science. That was the most part of the question paper here. So if you know the conversion part, because everything here, it's N3. This is your N3 stuff. All right, everything that we talked about here, there's nothing new that we had from our science N4. Everything was just from our N3 in this section. So it's right in our revision. If you have an exam like this, it's an advantage on your side. Anyways, it's an advantage on your side. All right, so that's it, guys. Shall see more questions to come.